of 0.5 microcoulombs. So if you're dealing with the microcoulombs, it is 10 times what? Or it's 10 to the power of what?
Is it minus 6?
The minus 6, yes.
Okay.
Micro 10 to the power of minus 6. Nano.
Nano is
10 to the power of minus 9.
Okay.
Yeah, now calculate the number of electrons. How do we calculate the number of electrons that were transferred? Number of electrons removed from sphere P. Before we even continue, sphere P is plus 0.5 microcoulombs. Does it have excess electrons or does it have shortage of electrons, and why?
It has a shortage of electrons.
Okay. Since this sphere had 0 coulomb, because obviously objects are deemed to be neutral.
Okay.
So a certain amount of electrons were removed. Then they're saying how many electrons were removed in this case. How do we calculate it? Do you remember this formula? So what is the value of Q? So what happened initially is that our sphere was neutral. And as it was neutral, it has plus 0.5 microcoulombs of charge and minus 0.5 nanocoulombs of charge. So if you add the two, you will get 0. You agree?
Yes.
So the sphere was neutral. However, someone came and took away this portion of electrons, and we were only left with a plus 0.5 microcoulombs. So the charges that were removed, 0.5 times 10 to the power of minus 6, all divided by, what is the unit charge? If you remember from grade 10, charge quantization. What is charge quantization? What is charge quantization?
Is it ish? Okay, I'll guess. So is it the principle that the charge of a specific object is can I say integer multiple?
Yes, the multiple of 1.6 times 10 to the power of minus 19. You remember?
Yes.
Okay, perfect. So that's exactly what we're going to put. 1.6 times 10 to the power of minus 19. So if you use your calculator, what do you get?
Um, I get 3.125
3.125.
times 10 to the power 12.
Yes. So these are the number of electrons that were taken out. So
Okay.
these are the number of electrons that were taken out. Okay. Now the charge sphere P is suspended from a light inextensible string. Another sphere R with a charge of minus 0.9 microcoulomb on an insulated stand is brought close to a sphere P. As a result, sphere P moves to a position where it is 20 centimeters from sphere R as shown. The system is in equilibrium. The angle between the string and the vertical is 7. The system is in equilibrium. So if the system is in equilibrium, what comes to your mind when it comes to forces? F net equals, we are talking about equilibrium. Ronel, if the system is in equilibrium, your force net will be?
Would it? Sorry, I want to say 0.
Is it not? It is 0.
Oh,
Yeah.
so
Yeah, so these are the key terms. If your system is in equilibrium, it means there's 0 acceleration. So your force net equals 0. Now, draw a labeled free body diagram showing all forces acting on P. Okay, the free body diagram of P. So which forces are we going to talk about? The first force,
is a gravitational force.
why gravitational force?
But it says it's suspended. Oh,
It is not standard. Who told you that P has mass?
oh, okay.
So it must have mass first. If it does not have mass, don't talk about gravity.
Okay.
Yeah, so we are going to be talking about an isolated system, a system whereby we are only going to be considering the given forces. If there's no mass, there's no gravity. So do you know any other force?
Um, no,
Do we have a string?
yeah,
So what comes to your mind?
tension.
Okay. We have tension. Okay. Do we have any other force?
Um, no, so I don't think so.
Okay. Small graphite coated. we do have electrostatic force.
Oh,
That is, you agree?
okay.
There's a force due to a sphere R. Do you agree?
Yes.
Okay. So we're gonna have electrostatic force okay. Um you said something about the force of gravity, right?
Yes.
Yeah, we were not told that the sphere is mass, but I'm gonna put it. The reason why I'm gonna put it is because if there's a force pulling the sphere upwards, it means um, there should be a force
Putting
that
it
should
downwards.
balance.
Um,
Yes. Even if I put it, or even if I don't put it, um, on our calculations, um, it won't make a difference. So let me see. Uh, okay. So we have force of gravity, that's fine. There should be a balance of forces. If I don't put it, it won't show that our system is in equilibrium. Okay. However, we don't have a mass that is given, but it doesn't matter. State the Coulomb's law in words. Coulomb's law in words.
um, the force between two charged objects is directly proportional to the product of their charge and inversely proportional to the square of their distance between them.
Okay. Okay. Product of charges and inversely proportional. Inversely proportional to
Inversely proportional to the square of the distance between them.
the distance between centers.
Yeah.
Perfect. Okay. So this is what we are talking about. You agree?
Yeah.
Okay. 5.4. Calculate the magnitude of tension in the string. 5.4. So what do? We are dealing with forces now. Where do we start? We have to resolve in a specific direction. Which direction do you want to resolve in?
Up and right to the positive.
Okay, we are choosing the direction upward, and there is positive. Perfect. Okay. Then what do we have?
So do we use the formula F net is equals to M A?
Always. Newton's law, when you're dealing with any form of force, whether it's electrostatics or gravitational force, whatever force.
Okay.
Yes. So which direction do you want to start with?
Tension.
The direction.
Upward.
A vertical direction in the Y,
Yes.
right? Okay.
Yes.
Okay. So what do we have?
So we have tension.
Okay. Let me add a page. So we're gonna need to. Okay. So we will have tension. 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 And then
So is that it? Because I don't see any other ones. Or the FS. Is it FY?
no, this FG.
FG. Y?
That's 7 degrees. You agree?
Yes.
Okay. Do we have a tilted force?
Yes, sir.
What is it?
Is it not the tension?
The tension. So we must resolve it. So it's gonna give us what? If we want a vertical component. Does your component form part of the angle?
Yes.
So if it does, it means it's a what? Is it a sine or a cos?
Is it a sine?
If it forms part of the angle, it's a cos.
Okay.
Cos of 7 degrees. Then what other force? What other force in the y direction?
We have the force of gravity.
Plus or minus?
Minus.
Minus Fg. Is equals to
M.
Ma.
Yes.
Okay. Is it not 0?
Yes. It's 0.
No problem. Okay. So do you agree that T cos of 7 is equals to mg? You agree?
So please explain that.
Okay, let me not confuse you. Let me do it step by step. Okay, I am going to take fg to the other side.
Yes.
If I take fg to the other side, I will have fg.
Yes.
Okay, so tension cos of 7 is equals to m times gravity. You agree?
Yes.
We are looking for tension. And do we have mass?
No.
No, we don't have. But we have gravity.
Yes.
Okay, so far that's all we can deliver in the y direction. Okay, so do you agree that we have to go to the x direction now?
Yes.
Okay. In the x direction, what do we have?
We have the electrostatic force.
F elect, then which is positive because it's in the positive direction, and then
And then so can I see the diagram again?
okay.
I'm not sure what other force we have going in the x direction.
Do we have a tilted force?
Yes.
Does it have components?
Yes.
Okay.
Okay. So will that be minus t sine
Yes, you are right
sine
because if yes,
sine
yes.
yeah.
Okay, then this is equals to
0.
perfect. Okay, do we have the electrostatic force?
Um,
Do we have it? Do we have it? Or do we have to calculate it?
I think we would have to calculate it.
Okay, so we have the amount of charges because electrostatic force has to do with charges. So
Yes.
K Q1 Q2 over R squared minus tension sine of 7 degrees is equals to 0. Your K will be 9 times 10 to the power of 9, right?
Yes.
Times Q1 is given by, what is the value of Q1?
Q1 would it not be 0.5?
Perfect. 0.5 times 10 to the power of minus 6 times the other one was 0.9, which was negative. Negative 0.9 times 10 to the power of minus 6. Okay, divided by what is the value of r squared? Oh, you have a question?
No, sir.
Okay. In fact, I can remove the sign, that's fine, to avoid confusion, as long as you know the direction, right?
Yes.
Okay. Now, what is the distance between the two charges? Okay.
20.
Okay, so what should I put?
How do you put 20 squared?
I can't put 20 because the units for R is meters. So that's where the trick is.
So please repeat that.
Your units must always be in meters.
Oh, okay.
Yes. So don't forget. So minus T sine of 7 degrees is equals to 0. So what do we get?
Let me just calculate that.
Okay.
So I'm getting 0.10125.
Okay, let me see on my others. Okay, you got 0, comma, ne,
Yeah.
minus
Yes.
t. What is the sign of 7?
That is 0. So how many decimal places am I rounding it off to?
It's better. You can make it. You can keep it 5 for now.
Okay, so it's gonna be 0.12187.
Okay. Then it's equals to 0. Now,
Yes.
so from here, what do I do?
Do you not take the 0.10125 to the other side?
Okay, no problem. So I'm going to be left with minus t times 0.12187 is equals to a minus 0.101 25. Okay, then to get the value of t, what should I do?
So you do not have to take the negative t and divide it by both of them, the minus one and minus, to get rid of the negative.
Okay, so can I multiply with that? Can I divide with that? You agree?
Instead,
You agree?
so
Okay. 12187. So what is the value of t? Hmm. The value of t,
it's gonna be 0.83080.
0.83.
080.
Yeah, let me keep it to 3 decimal place on the answer only. Then what is the units of tension?
So if you're gonna leave it to 3 decimal places, then it's 0.831.
Okay, perfect. 0.831. And what is the units? What is the units of tension?
Newtons.
Newtons. Perfect. Okay. So do you see that everything revolves around resolving your forces into components? And you're going to be doing it also in electrostatics, because they understand that most students, when they go to another chapter, they forget about the other chapters. You
Yes,
see?
sir.
Yes. Okay. Let me see if I have any other example. Okay. I'm gonna. Okay. Any other example that I can get? Okay. Um, no, let me not take this one. One the example. Okay. Yes. Why am I not okay? Yes. Um, you see the example on the board?
Yes, sir.
Okay. Um, what is Coulomb's law? Hey, I'm tired of defining this one. It means it's going to be there in your exam. That's the problem. let me skip. So Coulomb's law, no man. It's K Q1 Q2. That's it. 3.2. Now calculate the net force acting on charge Q3. Okay, 3 point charges Q1, Q2 are carrying a charge 6, 3, and 5 respectively, and are arranged in a space as shown in the diagram. The distance between Q3 and Q1 is 30 centimeters, and that between Q3 and Q2 is 10 centimeters. Okay, so how do we go about calculating the net force acting on Q3 due to Q1 and Q2? What is the first thing that I have to do?
Do you not have to pick your directions?
Let's pick our directions. Okay, that's positive. Then the second step, second step. Okay, I just want to write this one. A relationship is between two people. Two people, not three. So relationship between Q1 and Q3. The relationship between Q1 and Q3 has nothing to do with Q2. So let's say for instance, if you want to find the force between Q3 and Q1, Q3 has nothing to do with that calculation. And also when I'm determining the love between Q3 and Q2, Q1 has nothing to do with it. Even if Q3 and Q1 are in a relationship, they are in a relationship, but these two relationships, when Q3 is with Q1, Q2 has nothing to do with it. She must just stay away. Okay. But when Q3 comes now and meet with Q2, Q1 must not even intervene. The relationship has nothing to do with it. You understand? Or no, do you understand? I can't hear you anymore. Okay.